Welcome again, everyone, to the webinar. As I mentioned, there will be a CCA credit code coming up at the end of the webinar, so stay tuned for that, and we'll talk a bit more about that when we get things wrapped up. But I just want to introduce our topic today is maximizing harvest productivity, and we're fortunate we've got Les Hill. He's the Manager of Technical Services and Business Development with PAMI, the Prairie Agricultural Machinery Institute, and he's based out of Humboldt. He's been our lead speaker at a number of events that we've hosted, our combine clinics over the last couple of years, and we've challenged him today. His presentations at those clinics have all been, I think, 2+ hours, and we've given him an hour to cover some of the key highlights focused on finding that throughout his career he's got a lot of experience working on harvest losses and finding that best balance on different combines between productivity in terms of the number of acres you can cover versus what's an acceptable level of harvest loss. And particularly with the small-seeded canola crop, that can be a challenge. So as part of that, because he's a bit limited on time, Les has agreed to post his presentation. We'll be able to post that together with the recording of the webinar, and so you'll have access to his speaker notes on those slides as well. So we really appreciate that. The only thing he asks is if you want to use any of those slides, please contact him for permission. So with that, I think I will turn things over to Les, and he can get rolling.
Okay, again, today I want to cut the presentation down and try to hit some highlights as we go through, so we'll be moving along fairly quickly. And what I plan on covering is the difference between loss, or the impact of loss on productivity, and how that balances out. I want to go over some basic understanding of what's going on in the combine. I want to touch on adjusting the combine, again, a general way of going about it, and so that you can apply it to all machines. And then the critical part is in terms of understanding the loss and the amount of loss that you've got and how it impacts the performance and profitability. So moving right along, we know that at all times it's a balance. When you're out there running your combine and adjusting it, it's trying to find that magic balance between profit and productivity. Productivity, when you increase your speed, obviously the fixed costs go down per bushel. And just a quick example shows how going from 4 to 5 mile an hour in a 30-foot cut could drop your operating costs from about 8.4 cents per bushel. So that's a savings on 150 acres of about $630, which is not insignificant. So that's sort of the push, as well as the time saving that everybody is after there to get everything done in the harvest season. The balance in terms of the profitability is when you start losing an extra half bushel or a bushel an acre, it starts subtracting off whatever you gained in the increased productivity. So you can see a quick example there that 1 mile an hour, if it caused that extra half a bushel loss, by the time you get down to the bottom end of it, it's really still costing you about $120. So there was $750 of grain or seed thrown out for a $630 saving in cost. So it's costing you roughly $120, but you did save 2 hours. And in today's terms, $60 an hour for harvesting is not unacceptable. But that's a half a bushel. And when we start talking 1, 2, 3 bushels an acre, all of a sudden those prices go extremely high, and it can get even worse than that. So people have to be very conscious of what that's really costing them. Now, as we move on, basically all combines are going to perform the same basic functions of gathering, threshing, separating, cleaning, and then the material handling, which is really just the straw and chaff spreading, elevating the grain, unloading the grain, things like that. We won't touch on it near as much. We're going to concentrate on the first four. And it really starts with cutting. When we think of gathering, that's not just the combine. It starts right from the windrower or the straight cut head. And all of the things that you can possibly imagine adjusting on your windrower can play a significant role, plus some that you have no control over. So, you know, the width of cut is important, and we'll talk about how that comes about in terms of how big a windrow you end up with. The height, again, the same thing in reducing the amount of straw, but the real thing is how uniform that windrow comes out, and that's a function of the table angle and the knife angle, reel position, reel speed, everything that is happening on the machine, and then some of the things that you can't control, such as the wind and the natural lean of the crop. And one particular thing would be the swath roller, which I'll come to in a second. And this applies pretty much the same factors all go into a straight cut header. So those that are going to look at straight cutting canola, these are also the same important factors that you would find in the windrowing. And it's important to understand what the impact is going to be. One of the things that people should understand is that as combines get bigger, tend to be in the rotary size, people are putting extremely large cuts into them. But the nature of a rotary combine, especially a single axial flow rotor, is that it has a very small inlet. And therefore, if you can tolerate going a little higher ground speed with a little narrower windrow, you're going to get better performance, because as you start feeding more and more material, and if you get slugging going into the machine, that's going to cost you a lot of issues in terms of not only loss, but lost time if you're starting to slug the feeder house and plug and things like that. Now, conventional and twin rotor combines prefer a wider or double windrow, and basically they're just utilizing the entire working area that's available to those combines. I talked about the height of cut, and the reason that we talk about that is the amount of material other than grain and its impact on the combine itself. Most combine capacities are based upon its MOG feed rate, and MOG being material other than grain. I show a little demonstration. This was actually in wheat, but as we got rid of about 8 inches of stubble, cutting higher and higher, the grain capacity increased dramatically. So you can see some of those that by getting rid of 8 inches of stubble and still having lots of straw, increased our grain capacity by nearly 50%, and getting rid of another 8 inches up to 85%. Now, this isn't going to be exact for all crops, and some you're often limited to how high you can cut by the amount of stubble required to hold the swath up, or just getting below the pods may limit how much you can leave attached to the ground. So what you find, though, is that people need to understand is that where the crop is very tall and you're putting a lot more straw through, you're going to see and have to deal with reduced capacity of that combine. And if it's short and mostly seed and grain, your grain capacity can go up dramatically. Uniformity, as I said, is extremely important, and the reason being that anytime you get breaks in the swath, what you end up going then is your combine is actually going from underloading or no load to overload condition. And the average between that wide swing in loading conditions would not be the same as the average if you had a very tight band of variation as you travel along. So a nice uniform windrow is always going to be varying a little bit, but that average is going to be a lot higher than if you're going from overload to underload and back, because those are not stable conditions. A lot of that starts right at the pickup, and most people sort of push it around the field and never pay much attention to it after they've got their initial setup. But in reality, the pickup height is important. That should be adjusted for crops. Obviously, with those that are on the ground, you need to get down there and pick up. But if you've got a well-supported windrow that's sitting up on the stubble, there's no sense combing through right down to the dirt. You can increase that, because that's going to cause, at times, momentary slippage in that, and especially in heavier crops. The angle is important, because what we want to do is we don't want to pull the swath apart. So if you have your pickup speed a little fast and very flat, you might see it breaking ahead of the pickup. If you lift that pickup a little bit and slow the speed down, you might see it come up very nicely and feed into the auger. If you're going a little on the slow side with the pickup, you may see the auger pulling it away, and again, that's introducing a break in the swath, and it's going to start slug feeding your machine. So you want to have as uniform a flow as possible all the way through. And things like the auger adjustment for height above the floor or the stripper on the back side will affect it also in terms of how the material goes, and the float. So all of those are important in there, and along with the wind bar that's there, if it's down too low and it's making the crop hesitate, those all affect the uniformity of flow. Once you get past the auger, obviously the feeder has a chance to again introduce slugging, which is a part of chain adjustment. If your chain is too loose, it rides up and slips, and if it's too tight, it doesn't touch the floor and material builds up and wad feeds. If you've got a stone trap, it should be cleaned regularly, because as you get particles in there, pieces of stone or stick in there, it can impede the flow of the material, and you're going to start getting, again, slug feeding going through your machine. Impellers and beaters and things like that that are meant to move, as they wear, they're less aggressive and may start to slip. Same thing with the rasp bars. If they get overly worn, it's not going to feed as aggressively. And the concaves, again, the same thing. If they're bent or that, you don't get the same feeding from side to side, or they may be actually blocking the inlet slightly. I'd mentioned before that the roller plays an important role in which way the canola windrow actually is laid. Now, normally we always follow the windrower in the same direction with the combine, because that would normally give us head first feeding. What we find is that a lot of time in heavier crops, where the material comes out from under the windrow, more or less standing or slightly laid the way it normally would be, gets hit by the roller, and the roller, instead of just pushing it down, may actually push it forward in the same direction. So when you're out there combining, what happens is you may see that swath breaking apart more often, and the reason being is now you're trying to pick it up backwards. So turn around and try going the other way. Lots of times that will solve that issue. Maybe not the most convenient, but it will work, especially if you're going back and forth. It doesn't really matter. Now, threshing is really about getting all the seed out of the pod or the heads without turning it and damaging it too badly. So that's always the balance. Now we get into really the performance, and it is about balancing out some of these factors. Threshing, really simplified, is energy transfer, and it's really about getting it from the rasp bars on the rotor or cylinder, which are spinning and thus have mass in motion is equal to energy, into the crop. And so we look at how that affects us, and we see that what we've got there is the rotating bars impact the crop and also move the crop. So whether the crop is stationary and hit by a moving object or is in motion and runs into a stationary object, there is an energy transfer back through the seed, and that shock basically is what dislodges the seed. So if we look at it, we know that the raspbar speed is equal to energy and frequency. So the faster it's turning, the more energy it's got to give up, and that's the only source, and the frequency with which those bars pass a given point. The concave, which is more of a restrictor valve, keeps it there and increases the frequency, and the depth that it is also determines how close it gets to those bars. So you have less cushioning. The wider you open it, the more cushion you've got in between there, so some crop takes longer to be contacted and receive that energy. Now, some of the factors, obviously, in canola, it's usually not that big a problem. A lot of threshing is done by the auger up the feeder and into the inlet, and then right in the threshing section. A lot of it is already done, and it just simply begins separation. There are times when threshing can be a problem, and this year was a good example early on where crop was cut and in 3 or 4 days it was dry. Some of those pods did stay a little tougher and didn't break apart quite as easily. Took a little more threshing action to get the seed out of them. So those are things, typically canola that weathers for several weeks out in the field, that totally disappears and it threshes out very nicely. Now, in other crops, such as wheat and that are hard to thresh, what you need to understand is that unthreshed can be affected by the feed rate and the mog that's in there. The more straw that's in there, the more cushioning there is. And, of course, also the crop condition due to moisture, which whether it's dry or tough is going to require more energy to thresh it out when it's tough than when it's dry. Although when it's dry, it presents a few threshing challenges where the head becomes so brittle that it'll snap into pieces rather than doing complete threshing. So we watch for those things. Now, there are several things in there that control the threshing besides just the rotor. Some of the things you'd see is right at the stone beater and front of the rotor and that inlet. A lot of threshing action takes place there just on initial contact. So the speed, again, affects that. But we want to make sure that it flows smoothly and doesn't over-thresh there. In the concave area, the wire spacing makes a difference. Again, as I said, I was talking about the snap part of heads or broken up straw. The narrow wire tends to keep more large particles up on top. They usually don't have as much open area, so you get into concave with wide wires, they have more open area. These concaves are often blanked, sometimes just to move material around, but sometimes to keep the crop in there and allow more impacts without necessarily having to increase the frequency due to rotor or cylinder speed. The concave vane angle, we don't usually like to play with that because it's quite a bit of adjusting to go on to change them all. But if you get into a situation where it's either threshing too aggressively or not aggressively enough, by changing that angle determines how many times the crop is going to go around. Cage covers or other restrictions that you can put across bars and that to limit the opening, again, will increase the threshing action. Everything that happens due to threshing basically is going to end up going down into the cleaning system. Separating again, is as soon as it's threshed, we want it to separate. So we like to get it as quickly as possible away, because typically the seeds will fall out early, are relatively clean compared to the amount of chaff that's with it. The more threshing action and the farther it gets back through the system, typically the more chaff and material other than the seed is separated with it. So we try to minimize that. But it's really about getting the seed out of the straw. And that happens at concaves, grates, and walkers. Now, there's four really forces acting on seed to help it separate. One is impact, just the normal impact. It's like batting a ball. If it hits it, then it drives it away from it. So as the bars pass over, they tend to push it down through the concaves. You have gravity working for you. Most concaves are located on the bottom of the rotor or cylinder, and again, that's to take advantage of gravity, just pulling it down. The whole need for rotary combines came about with the increased separating force that you get from the centrifugal force of spinning material around. And the smaller the circle and the faster you turn, the greater this centrifugal force, the more it wants to spin away from the center. So that's been a major force in separation. And of course, we've used for years the old shaking method, which started from people in the early days using a fork to winnow the crop and sort of shake it and let the grain fall out, and the walkers. The problem is there that once they're mixed together, you get very little separation. If you can keep the grain and straw separated as it shakes, then it'll separate. But once they're mixed together, it's not nearly as effective. Some of the factors that are going to affect it, again, MOG is the biggest factor in separation. Once that feed rate is reached, because I showed you what happened to the grain capacity as we got rid of the straw, how it went up. But the reality was the MOG capacity of that combine really didn't change. So you just went faster to get the amount of MOG feed rate, and that's a processing rate that it's going through there. And that meant that you got more heads and more grain. So MOG is a huge factor. You can see in the right-hand corner there the graph which shows that as you increase your feed rate or speed going along, you can see how the separation changed between the long straw and the shorter straws. Again, that long straw has a totally different pattern where it starts losing earlier and it increases much more rapidly. And so that's a factor. And of course, then moisture and the roughness of kernels and things like that also play a factor in separation. Now, typically, your best separation and the highest efficiency is going to be under active elements that are actually, they've got one moving over something that's stationary. And it's based a lot on the open area. I mean, the more open area, the more separation you get. And that includes not only the seed, but also the material other than grain. And so we look down and we look and see a typical separation pattern from a concave, and you can see that in the first few bars, a huge amount of separation takes place. If we were to take, say, the first 4 or 5, almost 50% of the grain at a lower feed rate will fall through in that front section. And that's because the relative speed of the material moving through the concave is quite low. So it can now fall down or get forced down through the concave. But as it travels farther back on the concave, it's picking up speed and it wants to travel along the top of the bars along with the straw and everything else, and you can see that decreasing rate. And as you increase the feed rate, again, you're getting lots where it's clean grain right at the front coming out, but the same pattern, it decreases as it goes back. And the first one might say, well, that's because there's less grain. But you can see by the high feed rate with 38% going up onto the walkers in this particular one, that pattern didn't change, and it wasn't because there wasn't a lot of grain there. So it's important to recognize how concave separates. As I mentioned before, in terms of how you feed different combines, it's important. Now, when we talked about the single rotor, rotary combines are less sensitive to the formation of the windrow, whereas when we get into conventional combines, it's important to recognize that the formation of the windrow can have a huge impact on the separating, simply by the distribution of where the grain is going. So we've got three instances here where it's either straight, in the middle, or off to the side, and you can see what happens to the piles of grain under the walker. They shift from nice and uniform, where it's evenly distributed, to heavy in the middle, to heavy on the side, and the result is that the losses are extremely high the more you concentrate, because, for example, on the one where all the grain is on the side, one walker is trying to handle about 50% of the material grain going up there. And so its efficiency goes way down. So it's important to recognize this, because your windrows will change as you go around the field. And there are some things you can do driving. For example, you don't want to drive off center unless there's a good reason. If all the heads are on that way, you want to put the heads in the middle rather than off to the side. So you can't cure it, but you can help it out a lot by the operator driving and understanding what's going to happen inside of your combine as you're doing that. We move on to cleaning, and really there's two factors there. One is the fan and air supply, and the other is the sieves and the shaking motion. And really, the fan is supplying the air, and it has velocity and volume, and they're tied together. You can't get one without the other. And the sieve, there's two parts to it. There is the shaking motion and the opening, and it directs the air. So as you close the sieves down, it really acts like wind boards and will redirect the air sort of at the angle that you set that at. So in a cleaning system, basically with the feeding onto the shoe, typically you'll see a lot of them now using a ripple pan or a preparation floor, which is a sieve with some air going through it. But what it's trying to do is shake the grain to the bottom, because you can blow air through grain and take chaff out, but you can't blow chaff and straw through grain without moving it way back. So then you have usually a pre-cleaning air blast, and that's to get the lighter chaff airborne as quickly as possible, and you don't ever want it to come back down. The fan itself usually delivers an air blast that's quite strong along the bottom of the fan housing and again at the cutoff points. So what you get is you've got one blast of air going underneath the cleaning sieve, and if the cleaning sieve is very closed, it will travel underneath the sieve and either exit up through the tailing section or will just basically stall. But typically you'll find it going up through the tailing section. The top air blast along the top of there goes basically under the chaffer, and what you're trying to do is maintain enough air flow up through the chaffer at all places so the material doesn't sit back down on it, the material other than grain, and that'll allow maximum separation. Again, that's all dependent on the system design, some of the crop characteristics, how heavy the chaff is, how much straw and materials in there, and the loading itself. The distribution is critical on a combine because a cleaning shoe needs to have a uniform flow of material, grain and chaff, and it needs to have a uniform air pattern. Now, if the design isn't right, then that doesn't happen, and most designs are not going to be perfect. So what you need to do is try to redistribute the material to try prevent overloading in a specific area. Now, the type of chaff makes quite a difference as to how the machine is going to perform, and just basically long straw down on the cleaning system is a killer for most cleaning systems, and that comes about either from over threshing or trying to get excessive separation going and using too wide of openings and things like that on the wire spacings, and you get a lot of that down. And when crop gets very dry and brittle, you get a lot of pieces breaking off and going down. And they knit the material together and tend to spear, because when they turn into the airstream, the end view, they start mimicking what a kernel or seed would look like. So in cleaning, it doesn't really matter which line we pick, but typically somewhere in there you can see that feed rate is going to load it up, and it's not so much the grain feed rate, but again the chaff feed rate. And when it gets to a certain level feed rate, you can overpower whatever the cleaning system is capable of. Everything is based upon, as we move on from here, that the combine is set up properly, the components are in good condition, and that you've got reasonable experience with the machine, and whatever has worked for you in the past is not necessarily wrong. It's going to be, I may talk about something slightly different, but if it's working for you, don't worry about it. For those where it's not working, then some of the things that I talk about are going to be of use to you. Most combines will come with a quick adjust guide, or at least the operator's manual will have some settings in it. A lot of the new ones now have an auto adjust or a preset where you just simply punch the button and it moves all the things that need to be adjusted for a particular crop. But again, we have to be careful on that to make sure that what it tells you in the cab is really what's in the machine. And always got to go back and think about the basics and use common sense. Make only one adjustment at a time, see what happens. If you start making too many adjustments at one time and it doesn't work, you get very frustrated. If it does, that's fine, but if it doesn't, you are in big trouble because you don't know which one made it better and which one made it worse. So some of the habits when you're adjusting is make sure you walk around your machine before you start, just to make sure that everything is safe and buttoned up, ready to go harvesting. Start a warning. Usually I like to blow the horn a couple times before we start up to make sure that everybody is clear. And then it's a good habit to run adjustments through their range on a daily basis when you start up. This is to make sure that they have lubrication, and whenever you start, you should always move towards the open. So if you're going to readjust the concave, drop it first, so in case there's something in there or jammed up. So rather than starting off pulling against that force, same thing in the shoe, always open your sieves first, so any pieces of stone or stick or that's caught in there will open up and follow through. And you always want to listen for, when you start up, for any odd noises, because if there is something, you need to check it out. There's a reason for it, and you want to make sure you catch it before it's too late. Now here's where the settings come in. Initial settings, what I'm saying is whatever those recommended ranges are, for the cylinder rotor, go to the higher setting recommended. So if it says from 800 to 900 or 950, go to the 950. The concave, go to the smaller opening, so you drop it down, pull it back up if it says 10 millimeters is the minimum. Pull it up to 10. Fan, I'm going to give you an alternative that I think you can use, so I'll just skip over it. The pre-cleaner, keep it at the smaller opening because we don't want to overload the system yet with material that wasn't ready to be put into the clean grain. Chaffer sieve, now use a larger opening because we don't want the loss coming out the back. And the tailing sieve, I would more go to the mid-range because we don't want to plug the tailings while we're just getting set. And then the cleaning sieve, again, go to the largest opening. This just simply means we're going to thresh it out, we're going to separate it as best we can, and we're going to drop this material all the way through, and it'll go into the clean grain where we can look at it and see what kind of job we've been doing. Here's what I do for setting the fan. Basically, I get my driver to drive at about 1 mile an hour, so just so that there's a low, steady feed rate, and then for whatever chaffer and sieve settings I got, I keep getting him to bump the fan speed up until a few seeds start to blow over. And this is just a very few, not a lot, but just you know what's happened as you keep doing this is that you've added enough air velocity that it's going to help move those seeds all the way to the back end. And once you get to there, then you're ready to start moving the combine speed up to a more normal speed and start doing some checking to see what the performance looks like. Here's where we want to look. We want to look in the grain tank. We want to look for the volume of material coming in. We want to look at the seed itself, whether we're getting a good range of small seeds and large seeds, whether there's any grain damage, whether there's unthreshed parts, straw, things like that going into the grain tank. We're not going to do anything quite yet, but we have a look there. If you possibly can, open the tailing section and look on the return elevator and just see how if you've got a lot of grain or chaff or unthreshed heads that might be going in there. You'd have a look. And again, when you go to the shoe, you'll look to see what kind of pattern you've got coming off there. That's if you can get to that. A lot of them now are enclosed and run, which is a lot more difficult. It means you have to usually disengage the straw chopper and move it out of the way, which is a good thing to do when you're starting out anyway. Go for a little ways so that you can see what's coming off the shoe. When you catch the material coming off, you're looking for the seed loss, you're looking for the type of chaff that's there, you're looking for damaged seed blowing over, you're looking for unthreshed heads that might be there. And when you go to the separator, what you're again looking for seed going over, you're looking at the straw material coming out. Is it damaged? How much chaff is with it? Or are there any unthreshed heads on it? Then we start making the decisions of what to do. The first question you ask yourself is about threshing. Am I getting it out of the head or am I damaging it too much? Somewhere in between there, it'll always be a trade-off. There may be a few kernels left in the head, and you might have a few damaged kernels. The problem with damaged kernels is usually you'll only find about half of what really is occurring in the system in the grain tank, because the other half usually blows out. So it's important to always keep that in mind. Now, if you're under threshing, what you're going to find is that you've got a lot of long straw going over the separator, and there's going to be heads attached. The shoe load should be light. There's probably nothing in the tailings. The grain sample might look very good. If you want to increase your threshing, you increase the cylinder speed, reduce the concave clearance, or last resort, reduce the ground speed. When you go too far and you get to over threshing, the big one there is usually the seed damage. You want to watch carefully for that. You're also going to look at the shoe load, because you may just simply overload your shoe because you're over threshing. And that usually means that you've got chaff-like material coming over the separator. Now, to reduce the over threshing, you can increase ground speed if losses aren't a significant factor, or you can reduce the cylinder speed, or you can increase concave clearance. Separating, there's really only one thing there that tells you got poor separation, and that's free grain discharged over the separator. Again, you can go back, you can decide whether you can start playing your separation off against your threshing by increasing the cylinder or rotor speed. You can reduce your concave clearance, or you may have to reduce ground speed, just you're feeding it too heavy. There are some other things you can do. You can increase your open area by going to a wide space concave or changing the vein angle. You can't over-separate from the standpoint of saving too much grain. What you can do in over-separating is simply the amount of material that's going down on the cleaning sieve. And that, again, factors there are the ground speed, reduce your cylinder or rotor speed, or increase your concave clearance, or go to a narrower wire concave, or add concave blanks, or increase the vein angle. Cleaning, there's really two ways that grain come out off the cleaning system, and just as to differentiate them, because it tells you sort of what the system is doing, is one is where it's blowing. Now the seed will always drop off the last 8-10 inches of the chaffer. It's just going to fall in there regardless of which. When you're blowing, the chaff is beyond. And when you're sloughing, they're together. Now there is a situation where you've actually got both things happening at once. It looks like it's blowing over, but it's really because you ran out of air somewhere on your chaffer halfway back and the material sat down. So it's actually sloughing all the way to the end, and then usually maybe an air blast from the tailing section is a little higher and lifts it out, and it looks like blowing. So that one is a lot harder to identify, but it can happen. More likely what you will find is that your losses will occur only in certain spots, and that can be either due to uneven loading or an uneven air pattern. And so it can be a case where you're blowing the seed out on that side because it's underloaded and or too hot an air blast, or you may find it sloughing out due to the fact that too much material has allowed it to sit down onto the chaffer and it's walking its way out. Or there may be a poor air pattern where it doesn't have enough air to keep it airborne. Cleaning, the thing to remember in terms of how clean that sample is that if you've got a little bit of material in there, a few pods and ends like that, dockage only takes away from its own weight, so it's really not a penalty. It's a nuisance to handle, but seed, when you get it very clean and you start blowing it over, that loss never gets to market, and that costs you big time. So you have to think about the balance there. If it means saving the seed, take a little dirtier sample. One thing people usually have trouble with too is the amount of material that's in the tailing section, whether it be grain or trash. I mean, ideally it would be just unthreshed heads, but typically it's the other two that are the issue, and you got to remember how it might have got in there. It can either travel over the chaffer and fall through the tailing section, or it can fall through the chaffer and carry over the sieve into the tailing. By closing the tailing section right off, you can determine which direction it went, because if you closed it right off and it was going over the chaffer and down, then you should find that it disappears out of the tailings and it should increase going over. If nothing happened, it meant that it fell through the chaffer and carried along, and therefore you have to start closing down the chaffer or increasing the air up to the chaffer to keep that material up there. Whereas if it was going all the way to the back and falling through, then you would probably, if it was seed, for example, reduce the air or increase the chaffer opening. So depending which way it's going, you pretty much use opposite settings. When do you stop playing around and decide that you're at your optimum? Well, the first thing is to recognize where your machine is operating. And by checking at different speeds, you can sort of create your own graph as to what those losses are like. So if at 3 miles an hour it looks good, and at 4 you're not happy with it, then somewhere in between there's a transition in the way your machine is performing. And you need to decide then what is the most economical for you. And again, we go back to that decision as to how much is it actually costing you in terms of the loss. So you're balancing out your productivity against your cost of the loss. And you need to be able to measure loss. And a couple things you need is equipment and technique. What I've found works very well is I make up a little pan on an extendable handle. You can get basically a dish pan down at the hardware store, take the head off a foam mop and screw a handle in and put a couple bolts through, and you've got yourself a quick and easy to use little pan. And you can use it for spot checking all along, or you can go with a wider pan, and it doesn't really matter what the pan looks like. It can be rectangular or it can be square, but you do have to know how many square feet are in that pan so that you can estimate what your losses are. For cleaning, screens work. Little portable blowers such that they use for air mattresses beat the heck out of trying to blow multiple samples out. And you can also use a bigger tub and a leaf blower and dump your sample in there and then use the leaf blower to blow the chaff out. And it takes some practice, but you can get it at idle usually so that you get the straw and chaff out without blowing the seed out. Those are good when you're taking bigger samples, 4, 5, 6 square feet or more. In terms of measuring the loss, there's 4 ways: weight, volume, you can count seeds, and there's a visual comparison of area. And we'll just touch on those. But the first thing is you need to catch the material, and that means to be accurate, you can't have your chopper and spreaders operating. You need to be able to drop the material down sort of in a band, and the trick is to get the pan onto the ground, let the combine pass over as the discharge lands in the pan. Once you've got it sorted out and you've caught it, then you want to look and determine how much is it. And we've provided, and you can find these on the Canola website too, is the seed loss guide. And what it is just a little card that has some charts on it. And the first thing you have to know is you're dropping that material out of your combine, it's landing in a band. Is it 4 feet wide, 5 feet wide, 3 feet wide? That's all you need to know. And then you go down the chart into the gray area and you look for the windrow size that is approximately the same as what your cutting width is. So in this case, let's assume we're dropping it in a 5-foot band behind the combine and you're cutting with a 30-foot windrower. You've got a concentration factor of about 6. So for every 6 feet of cut width, it's going to land in 1 foot behind the combine. And most combines will probably run in that 5 or 6 concentration factor there. So it doesn't change a lot. The first charts you will see is the weighing chart, and that would mean you need a little scale. So when you've caught this and you sort it out, typically per square foot, or if you've got 3 or 4 of them, you're going to have to divide that out to get per square foot. So when you put that seed on the scale, and that little scale says 2.9 grams, so you would use that chart, and the first one is weight, so it would work for a weighing mechanism. The second one is volume, and you can get these little vials that are graduated in milliliters. Those you would pour the grain into, and it'll give you a rough estimate, but that's by volume rather than by weight. So if you're using the weight, and we saw that there was 2.9 or roughly 3, and we had a concentration of 6. So on the green band up there in 6, and we drop down to 3.1, which is close to the 2.9, and go across, that's about 50 pounds, 48 to 50 pounds of seed loss per acre. You can work it backwards, so you can also pick other ones. If you said, I don't want to lose more than a half bushel, you'd go 25, and you'd go back and you'd say 1.6 grams under the number 6. So that's how you would go about weighing. For wheat and barley, there is one there that's a kernel count on 2 more charts. And again, if you're out there and you don't have any other way of looking at it, you can just count the kernels. And they'll give you the number. Typically, there's about 20 kernels per square foot over an entire acre in wheat to be a bushel an acre. And in barley, it's about 14 or 15. So then you concentrate them behind your combine and you multiply by that. So if on 6 and 20 you'd have 120 kernels of wheat, would be about a bushel an acre. Now, more likely what people are going to use would be the area down in the corners there too. If you don't want to count them and you scoot them into the corner of your pan, there's some visual triangles there that give you an idea whether it's a bushel or a half a bushel or a bushel and a half. So in canola, if you've got a 2-inch by 2-inch triangle in the corner, you've got about a half a bushel. If it goes to 3-inch by 3-inch, it's about 1 bushel. And barley and wheat again, and you can pick your different crops, and it's all there to help you understand what your amount of loss is. Now, the amount of loss that's acceptable is, going to depend on how fast you need to get your crop off. It's going to depend on how much it's costing you and the performance of the combine. Now, what we're working on when we're adjusting is getting that performance of the combine. On this curve here, you can see that the lowest loss is going to be about a half a bushel an acre at 3 miles an hour, and that it doesn't go too bad because you can go up to 4 and get up to 1 bushel, which is somewhere in there. So you're probably going to maybe be running somewhere between 3 and 4 miles an hour to be economical, to get maximized productivity. And every combine is going to be different in every different crop. So there are going to be ones where you can't get down as low as you would like, but you have to know where does it change. If I go slower or if I go faster, where does it change? And that's all part of making that loss catch accurately. So you can see from an efficiency standpoint, we said 3 to 4 might be better on this particular one. It'd be nice if we had that little graph printed out, but it's not always available. So you have to decide, do you go or do you slow down? And, as I said before, sometimes the loss is going to be too high and you're not going to be happy with it, and adjustments just aren't going to take care of it. And you can't slow down, and sometimes the conditions aren't ideal. And the biggest thing is sometimes the loss monitor isn't going to tell you really what's happening. And the reason is that loss monitors only work if they're calibrated to that loss out there. So unless you're actually measuring the loss, and when you decide that loss is too high, you have to adjust your monitor so that it shows you that it's too high. And where it's acceptable, it's down in the lower area and you can reference to it. It's always important, just as a reminder, that when you're out there working at that end of the business end of the combine, that it's a very dangerous situation and you should protect yourself. Make sure you've got a dust mask, goggles, and protect your hands with some gloves. Have a first aid kit in the combine, and be aware that of the dangers that are around there. The tire that might swing out quickly if the operator decides he's going to turn, truck driver driving too close by, things like that. So be aware and be safe as the harvest goes on and you're out there. And that concludes a quick overview of the normal presentation. So we'll open it up for questions.
Into the questions and switch over to that. Just a couple of quick comments. First of all, I mentioned that there was a CCA credit available under the crop management area for this, and so this is the code that you will submit. When you go onto our webinar section of the website, there'll be a link there that you can go to, and that'll take you to a few questions to submit the information we need to submit for that credit on your behalf. And I just want to thank Les for a great presentation. Don't have too many questions. I think lots of people are eager to get out there and actually use what you taught them this morning. And I see one comment here just says applause, so that obviously the audience appreciates, but we do have a couple of questions. One other thing I'll just mention, looking at Les's slides, I noticed he had the Alberta Canola Producers Commission logo in the corner. These are slides that Les used. We had a combine clinic this summer up at Westlock, Alberta. That's the last combine clinic in our series that we've had, or the most recent one. And just want to acknowledge that the webinar program is part of our extension program, and it's supported by all the provincial grower associations. So in addition to ACPC, want to thank SAS Canola and the Manitoba Canola Producers Association as well for their ongoing support and input into our program. Just a couple of quick questions, Les. One here, Kent asked, part of his question I'll maybe deal with. He asked about the extreme heat that we've been having recently, pretty much across the prairies, but he's from Alberta. And so with the canola going down in that heat, he was asking about the odds of green counts. Obviously, that will depend a bit. If our recommendation now is to swath it up to 60% seed color change on the main stem, the closer you are to that, the greater the opportunity that seed will manage to cure out before the swath gets too desiccated and those enzymes that clear the chlorophyll shut down. If you're swathing a large number of acres and you're swathing some of those early fields on the greener side, say prior to 30% seed color change, then obviously the odds that it may not completely cure out sufficiently before that grain gets dry enough to combine. Once it's dry enough to combine, those enzymes are pretty much shut down, and then you're looking at the decision of potentially waiting for some additional moisture to finish off that curing process. But what this also raises, I think, Les, with that recommendation, a lot of growers are waiting a little longer to swath, and as a result, they're finding that often they've got green counts down to that number 1 grade in a week to 10 days in some cases, and so the straw is often a lot less weathered than in the past when it would sit out for 2 or 3 weeks through a fair amount of rain and get fairly weathered, and it would break up a lot more as it went through the combine. Would you have any specific tips from the combining end of things with regard to things to watch for when you're setting up the combine, if you know that straw is either less weathered or more weathered and more prone to breaking up?
Yes, there's a few things. This year, I know it mimics some other years where I've seen it dry down very quickly, and really the swath tends to not turn the dark brown color, so the enzymes haven't done their thing on the straw. What happens is typically the straw itself tends to break up in pieces now rather than turning to powder, because if you take a well-weathered stalk and it goes through the normal process, it'll come out pretty much, everything that goes down to the shoe anyway is often almost powder dry, and the wind takes it out. The normal airflow of the combine will take that out. This year what you're apt to see is the stalks will break in pieces and not smash lengthwise and break apart, and those are going to give you a little more grief, so you may end up having to run a little narrower chaffer opening on those just to keep them out of the clean grain.
Okay, great. Great comments. Thanks, Les. And the other question that we do have here is something that's come up, I know, at the clinics, is the idea of doing a kill stall to figure out how the grain and straw and chaff are moving through the combine. And so the question was just what's the general procedure for a kill stall?
Well, generally, you want to stop the combine as quickly as possible. It used to be quite a bit easier where the fuel and the electrical systems were not tied together, because they're under load. What you would do is you would simply pull the fuel stop out and step on the brakes at the same time, and then disengage all your drives and restart. Now what happens is that you'll typically, if you shut the key off, you shut the engine off, but you also disengage all the drives, so you don't have the drag to slow you down. So what some people have been doing is simply just throttling right down and stepping on the brake at the same time, and leaving the hydro ahead, so that you're using up your power very quickly and kill the engine, then disengage and restart your engine. It's not as effective as it used to be, but it still can be done.
Great. Well, I think those are all the questions. If anyone else has another question, you can type it in right away. One question, I guess, I had somewhat related to what we were talking about before with the less weathered material. We have been getting, I know, some of our agronomists questions about straight combining canola, and some growers looking at doing a portion of their acres that way. Especially this year in some areas with the stress on the crop, it's short and not a lot of stubble to anchor those swaths. But one of the issues often, we want to get in there as soon as we can to minimize the potential for weather to cause shattering loss, and often the seed will be cured, but the straw going through will still be fairly on the green side and tough. Any suggestions, Les, of things you can do to help combine that kind of material as effectively as possible?
Well, this year the trade-off might seem a lot less of an issue, because where if you've windrowed it, you're getting excessive breakup. So this might be a situation where that's actually to an advantage, where you're going to be able to keep some of that straw and in the separator and discharge out that way, rather than putting it down onto the cleaning system. On some years, that's going to be an issue, is that if you got those pieces of straw and things like that in there, you may push your separator loss up a little bit, or it may end up, if it's on the greener side rather than just more resilient, I guess. If it's on the greener side, then obviously it's going to, and it gets down to the shoe, it's going to be heavier and more mimic the seed, and you have to switch from more of an air separation system to more of a sifting or shaking separation by closing down the chaffer and reducing the airspeed. Okay,
great. Les, and we did have one last question come in. Any tips on combining on side hills versus on the level, and things you can do to try and minimize loss?
Again, without the self-leveling shoe on there, anything over about 3 degrees, you're going to start seeing material moving to the downhill side. So if it's a windrow, what you can do is obviously feed it farther up on the uphill side if it's a conventional. If it's a rotary, it isn't going to make a lot of difference, because it's how it separates under the rotor rather than where it actually went in. But if it's a conventional combine, then move your swath to the uphill side so that it starts there and moves across. Obviously, you're going to have to, slowing down is going to help, because if you're running on the flat where it's pretty much met its efficient range there, that efficiency is going to drop off on the side hill, and you're going to have to back off on feed rate.
Okay, great suggestions. Well, I think that wraps up the questions related to managing loss. The only other question that someone had was about accessing the recorded webinar, and so I still have up on the screen the information on how to access your CCA validation code, but this address here, canolacouncil.org/webinars, all of our past webinars are posted at that location, and as soon as our staff at the head office gets a chance to get the recording set up this afternoon, they will have today's webinar posted there as well. So with that, I would just want to thank Les again for his informative discussion today, and I hope everyone has a successful harvest for the rest of the harvest. Bye for now.
Bye now.